Okay, so I do want to remind you guys that every question I do with you guys could be either just a question on it, or it might represent 2 or 3 different types of questions on it. So, you know, if we only do like 20 problems at the end of the 3 days of review, and you're like, well, wait a minute, you said there were 37. We're 17 less than that. Well, no, we probably covered everything. We just don't need to redo so many of them, right? So, for example, simplify for question number 1, that actually covers 2 different problems. Okay, so but the second one I think is easier than this one. But all right, let's get started with question number 1. Okay, so simplify. And when they say simplify, notice it's just a fraction. So all you have to do is basically factor, and then once you factor, cancel stuff out, and you're done. Okay? So, let me go ahead and do that. The numerator, I can factor out an x. So I'm going to take an x out, and then I have x plus 6. Okay? So there's that part, x and x plus 6. The denominator is a trinomial, so I'm going to have to do this using the x method. Okay, and you're going to notice we're going to do the x method a lot today, okay? So, on the bottom, the x squared plus 3x minus 18, I got to multiply a times c, that's 1 times negative 18, that goes on top, and then your b value, which is 3, that goes on the bottom, okay? 2 numbers that multiply to negative 18 that add up to a positive 3 will be a positive 6 and a negative 3. So this factors into x plus 6, x minus 3. So let me write that into my original problem here. X plus 6, x minus 3. What can I cancel? Oh yeah, go ahead. So what am I able to cancel? I'll wait after them. But what should I cancel right now?
X plus 6.
All right. So the x plus 6's can go away. Like I said, right now I'll hold on at the end. And basically what you see there, what's left over, will be your answer. Okay? So it's going to be x over x minus 3. And that's it. So let's go over question number 2. Now you're going to notice question 2 says divide. Okay? And I'm not sure why it's not moving. Give it a second. So it says divide, and that means that the reason why I did a division problem is because there's also multiplication problems. But when you divide, you have to multiply. So by doing one division problem, I covered 3 different types of problems. Okay? So, and then there's a little note right here at the bottom that I'll kind of let you guys write stuff out once we're done, okay? But let's worry about the problem at first. So, you guys, when we did this the first time, I told you guys, you do not divide fractions, you multiply by reciprocals. Okay, so your very first step is going to be to rewrite this. So the first fraction stays the same. No need to do anything to it yet. But instead of division, you're going to put a multiplication. Okay, and then you flip the second fraction. So n minus 2 and 3n. So that's your very first step, is to rewrite it as a multiplication problem. Again, this is why I'm not going to do any multiplication problems for practice, because we're going to do it here, right? So division becomes multiplication, and then it's basically just a multiplication problem from now on. Now, you're going to ask yourself, can I factor anything in these problems? So look at the n minus 4 up on top. There is nothing I can do to factor that, so I'm going to leave it alone. But 7n minus 28n, I can factor stuff out of that. So let me write this out. N minus 4 over, what can I factor out of 7n squared minus 28n?
N.
And what else?
7.
A 7. So this will make it n minus 4, okay? Times, now n minus 2, I can't factor anything out of that, so I'm just going to write n minus 2. and 3n is just 3n. What can I cancel from there? Remember, you can cancel top to bottom or diagonally, but never side to side. Yeah, the n minus 4 is going to go away. So this is what I have left. N minus 2 over 21 n squared. And that's it. You cannot cancel these n's right here. Sometimes people are like, oh, you can get rid of one of these because, they both have it. You can't do that. Okay, don't do that. The only way you can get rid of a single n, if there's another single n on top and bottom, but they can't be connected to a binomial with addition or subtraction. So the one on top, it's stuck. N minus 2, it's stuck like glue. Okay, you can't break it apart. The only way you can get rid of that n is if you get rid of the whole n minus 2 all at once. Okay, you can't just little pieces here and there. Okay, so there's your answer for division. And again, division became multiplication, so I don't have to do a multiply problem, okay? But check out this note. I want you guys to write it down, because we're not going to do a problem like this because there really is no need. We just did one. But it says, if they give you a compound fraction, okay, a compound fraction is when you have a fraction with two fractions in it. Okay, one on top and one on the bottom. So it's a fraction within a fraction within a fraction, right? Actually, it's two fractions in a fraction, not three. So all you have to do is rewrite them. So you write the numerator first, so n minus 2 over 3n. And then write divided by, and then write the denominator, n plus 4 over n squared minus 2n. At that point, what are you supposed to do? What's your next step? Yeah, you flip the second fraction and you make the division into a multiplication. Okay? So your very next step would be to change this to a times and flip this over. Okay? You want to flip it over. And at that point, now you have a multiplication, just like we did up in the previous problem, and you're good. Okay? So we're not going to do this problem for the most important reason why is because I just made this problem up and it actually doesn't turn out to be a nice answer. So I don't even want to bother with it. But I just want to make sure you guys understand that if you see, you will see, actually, not if you see.
To write that problem?
Well, it's just more of an example to show you how to rewrite it. That's all. So if it looks like a fraction in a fraction, you rewrite it like this. And then you do what we did in example 2. You flip it and multiply. So it's just a way to tell you when you see a question like this on your quiz, because you will see it, okay? You're going to see 1. Make sure you rewrite it and then multiply and flip the second fraction and then start simplifying, okay? Simplifying might involve factoring and all this other stuff, so. All right, are we good with the blue stuff? Not yet? Go ahead.
Is that supposed to say and follow?
As follows. Yeah, AS. All right, so I'm going to move this up. And remember, guys, if you're writing notes and you aren't able to write something down, remember these notes are coming to you guys later on, so you can always just catch up on something. That way you can write everything that was written for you. Okay? Like one of my students actually prints these out. Every single thing I write, he just prints them out. Yeah. The problem is they're in color, so you're gonna waste a bunch of color on your printer.
Why don't you just do it black and white?
You might, but sometimes the color doesn't show up nice. You can try it. I don't know, but I have a student in my calculus class. He prints everything, so he doesn't want to take notes. He wants to watch as I'm doing it, and then after he's done trying to understand, then he'll go home, print them out. Now he has notes. So, but yeah, that's why I sent them to you guys. Use them however you want. All right, number 3 says if y varies directly as x, and y equals 15 when x equals 12. Find y when x equals 32. These are easy problems. They don't look like it at first, but you do have to understand what kind of formula am I going to use. Now, you can tell that they said it varies directly. Okay, now there are two types of formulas: direct variation and inverse variation. We're going to do one of each. Okay, so they said y varies directly as x. As soon as you see that, your quick reflex should be write this: y over x equals k. Y over x equals k. You do it twice, because the first time you solve for k, the second time you solve for whatever variable they need you to solve for. Okay? So, how do we figure out what to write? Well, keep reading. After the highlight, it says, if y varies directly as x and y equals 15 when x equals 12. So y is 15 when x is 12. Well, that's 5 over 4. That's my k value. So all I got to do is get the k value, and I'm going to plug it into the other one.
The K stands for varies directly?
No, the k is the constant of proportionality. But you need, since there's 3 variables in the equations, you need 2 in order to solve for the missing one.
What's the missing one?
Well, right now we're going to find it. Find y. Right? That's going to be the missing one. So the first piece of information is going to give you enough to find k. Once you find k, you're going to plug it into the other equation along with the other piece of information. What do they tell us? They say find y when x is 32. So x is 32. Let me write that stuff down here. Find y when x is 32 and k is 5 over 4. So whenever you have a fraction equal to a fraction, you cross multiply. All right, you're going to cross multiply like this. So you get 4y equal to 160. All right, and then divide both sides by 4. So y is 40. And that's your answer.
Can you explain?
All right, so let's go to example 4. Okay, I'm going to give you a little bit of time to write this out because it is like a paragraph. So let me give you a minute. All right, so like I mentioned before, these are very much kind of like the same as the ones that we just did. I'm going to highlight varies inversely, okay, because that's kind of the key to this problem. So it says the width of a rectangle varies inversely with its length. If the width is 4, then the length is 18. Find the width when the length is 8. Okay? So remember, I think you guys need to assign letters to your dimensions. So I'm going to let x be the width. I'm going to let length be your y. I'm going to let width be your x. I said that wrong. And length be your y. Okay? So, what is the formula for inverse variation? It is xy equals k. Remember, write it 2 times. The first time we're going to solve k. The next time we're going to solve for whatever they need. So, let's see what they say in that sentence here. The very first sentence with information. They say, if the width is 4. Remember, width is x. If x is 4... then the length, which is y, is 18. Well, 4 times 18, that's 72. So I just solve for k. Alright, so now I'm just going to plug that into my other equation along with some information they give me at the end. The very end says, find the width, in other words, find x, if the length is 8. So if y is 8. So here we go. Whoops. X times 8 equals 72. Well, that's 8x, right? So you just divide by 8. So x equals 9. And you're done. So that's how you would do an inverse variation problem. It's very, very similar to direct variation. It's just a different formula, but it's same idea. Plug in your information, solve k. Second time, using k and a new piece of information, solve for the missing piece. By the way, like I said, we do have 7 problems. We're going on 5. We got 3 left. The next 2 aren't too bad. The 7th one takes a while, okay? So I'm just kind of warning you now. Any questions on number 4? All right. Subtract and simplify. Now, let me erase that stuff off my board. All right, now what you're going to notice is this looks kind of intimidating, right? But one thing you guys should notice is the denominators are the same. When denominators are the same, adding and subtracting is not that big a deal. Okay? It really isn't that big a deal because the denominator doesn't change, at least not at first. Okay? So, if the denominators are the same, all I have to do is combine the numerators. So here we go. 2x plus 10 minus x plus 5 divided by x squared plus 6x plus 5. That's my first step. Now let's simplify the numerator, right? We're just going to subtract like terms. Okay? So 2x minus x is x. 10 minus 5 is 5. So if you get your answer and leave it like this, you're almost right. But you're not done. Because what can I do with the denominator?
X method.
I can factor it. Yeah, the x method. So let me put that right here. 1 times 5 is 5, and the 6 is my b, so that goes there. So give me 2 numbers that add up to 6, but multiply to 5.
5 and 1.
5 and 1. So plus 1 plus 5, that'd be x plus 1, x plus 5. Let me put that into my original problem. So x plus 5 over x plus 1, x plus 5. That's my factored form for x squared plus 6x plus 5. What can I cancel?
X plus 5.
All right, so x plus 5s are gone. So here's my final answer. 1 over x plus 1. That's my final answer. So it's not that the previous answer was wrong. It just wasn't simplified, right? If you remember the instructions, it said subtract and simplify. So you got to just keep going. Check. Now, if you couldn't simplify anything, that's okay. But you have to at least try. Try to simplify it as much as possible. Any questions on this one? Again, these are a little bit tougher because of the fact that, these are a little bit easier because of the fact that they have the same denominator. Okay? Right now I just had a thought. Do we only have 7? Yeah. I think we have more than 7. Let me see. 6, 7.
It was 1 over x minus
1. Oh no, we just have 7. 1 over, yeah, x plus 1. 1 over x plus 1. I thought we had more than 7 all of a sudden. I'm like, wait, did I mess up? But no, it is 7. All right, these last 2. Question 6 is not as bad as question 7. Question 7 is pretty lengthy, okay? So you have to bear with me on that. But question 6 is helpful for question 7, okay? So if they want you to solve for x, but you got a bunch of fractions and stuff like that, I've told you guys before, and as many of you guys probably feel the same way with me, fractions are not my favorite thing. They make everything look more difficult. So what you want to do is you want to try to get rid of the fractions in your problems. The way you do that is by finding the LCD. Okay? So here's how I showed it to you guys. I said get every denominator that you see. Okay? So I see a 3, an x, and an x. And what you're going to do is you're going to list all the numbers that are there. So I see a 3 and all the letters. So I see an x and an x. And for your LCD, you're going to take those. So I only see a number 3, so I'm going to write a 3 there. I see a letter x, and I don't know if you guys recall when I taught this to you guys about a month and a half ago. I said take the letters or the expressions and take them to their highest power. Well, the two x's only have x to the first, so I'm just going to write x to the first. Okay, so that's my LCD right there. Okay, this is my least common denominator. So what I'm going to do is multiply my original problem by 3x. Okay, every fraction by 3x. So here you go.
Multiply.
Yeah, so it's going to look like this. It gets a little messy, but just try to be nice and clean. That way you don't have like things all over the place because you're just not being careful. But try your best to keep it nice and clean. For me, I'm using different colors, so it makes it a little bit easier to see what's changing. But that's what I'm going to do. I'm going to multiply everything by 3x. Now my job is to try to simplify this. Okay? So I'm going to look at this stuff right here. 3x divided by 3. What can I get rid of 3x and divided by 3? The 3. So I'm going to cancel that out. 3, 3. So what's left is a 5x minus. What can I cancel between the 3x and the x on the bottom? An x, all right. So 3 times 2 is 6. What can I cancel on the last one? An x as well. So 3 times 8, 24. Now notice how nice and simple that turns out to be, right? It's just a normal linear function. Not even a linear function. It's just a normal one variable function with 2 steps in order to finish this problem. So I'm going to add 6 to both sides. So that's 5x equals 30. And then just divide by 5 and you're done. Okay, like I said, this is considered an easier problem. You will have something on the easier side on your quiz, but then you're also going to have one that's a little bit more complicated. Actually, a lot more complicated. So that's the one we're going to end off on. Okay, so we have 17 minutes before class is over. We're ending with this one because I might take about 10 minutes or more. Okay, just because I'm taking my time with you guys. All right, I can do it faster in my head, but if I'm writing it down and explaining, I can't rush through it. So yeah, just be patient with this last problem. All right. Any questions on question number 6? All right. So here is question number 7. Yeah, go ahead. So go ahead and write that down. I'll give you about a minute and a half. All right. So, in order to do this problem, we're going to have to do the same thing that we did in the previous example, which is to get the same denominators, okay? But notice how I have this trinomials, set of trinomials on the bottom. So first I got to factor those. So let me do that. Let me factor x squared minus x minus 6. So 1 times negative 6 is negative 6. And the b value is a negative 1, so I'll put that there. I need 2 numbers that multiply to negative 6 that add up to negative 1. That would be a negative 3. Actually, it's a negative 3 and a 2. If I use a 5 and a negative 1, it'll multiply to a negative 5, not a negative 6. So yeah, negative 3 and a positive 2. So that means this will be x minus 3, sorry, x minus 3, x plus 2. I actually made a mistake with the other class and I miscopied something, so I'll make sure I don't do that this time. So let me rewrite this whole problem here, okay? So this is why it takes a while, because there's a lot of times that I'm just going to rewrite stuff. X minus 3, x plus 2 plus 2x squared plus 4x minus 6 over x minus 3, x plus 2 equals x minus 2 over x minus 3.
Wait, so you just have to, how do you know that's the least common denominator?
Oh, I don't know yet. I haven't even done it yet. But first I had to factor. First I have to factor. And now I'm going to find the LCD.
Oh, because they're both the same one? I thought they were
Yeah.
different.
Yeah. Oh, no, yeah, they're both identical. Correct. So, yeah. But go ahead and write that down. And our job right now is to find that LCD. That's our next job. And you're going to basically list your 3 denominators, one on top of the other. So let's go ahead and do that. X minus 3, x plus 2, that's one of them. The other one is x minus 3, x plus 2. And the last one is just x minus 3. Okay? And I got to figure out my LCD. So remember, you're going to list all your numbers. Well, I don't have any lone numbers out there, so that's fine. You're going to list any lone letters that are there. I don't have any of those. And then you're going to list any binomials or anything else that's there. Notice I have an x minus 3. There's 3 of them. But what's the highest power on it? Aren't these all 1s? Right? They're all 1s. Right? So it's going to be x minus 3 to the first. And then I also have x minus 2. Now you might say, well, the last one doesn't have an x minus 2. X plus 2. You might say the last one doesn't have an x plus 2. That's okay. With the LCDs, they don't all have to have it. Okay? You just got to list everything that's there. And notice the highest power on x plus 2 is also a first power. Okay? That's my LCD. Okay? This next step is a pain, and I apologize. Okay? All right, so the step where this gets a little bit not difficult, just messy is coming up, okay? So let me zoom out a bit so you guys can see it. I'm going to multiply that whole problem in red by my LCD. So I'm going to move a little quick because I know we're running out of time, okay? So maybe if you just want to watch right now, and then later on you can copy it. If you're kind of like, I may not be able to catch them up, I would recommend that. Okay? If not, it's okay, just write it out. But notice I'm multiplying everything on the other equation by my brand new LCD. But it's just going to take a little while because there's a lot to write. Most people do this in their head, just so you know.
How?
It's because what you're going to do is you're going to say, okay, I got an x minus 3 and an x plus 2, and it's next to this fraction. It'll cancel out everything on the bottom. Like they can do that in their head. But some people can't, so you got to see it, right? And that's why I'm saying this gets a little messy, so just take your time writing it out. And like I said, if you don't want to write it out right now, just watch. That's fine. X minus 3, x plus 2. Give me a second here. I'm going to cheat a bit. I'm moving it down. So, okay. So once you do this, I'm going to cancel out stuff all over the place in the denominators. Notice x minus 3 x minus 3, x plus 2, x plus 2. That's gone. Okay? Look at the middle one. X minus 3, x minus 3, x plus 2, x plus 2. Look at the last one. Almost everything, right? There's still an x plus 2 on the end, but that's okay. Let me rewrite what this looks like. X minus 4 plus 2x squared plus 4x minus 6 equals x minus 2 times x plus 2. Now, just like I did with the other class, I'm going to take a couple steps a little quicker right now, okay? So, just so you guys know, I'm going to combine the left side terms together. You're going to get 2x squared. X plus 4x is 5x. And negative 4 plus negative 6 is negative 10. X minus 2 times x plus 2 is called a difference of two squares. When you multiply those together, you get that. X squared minus 4. So you would have just distributed, okay? I'm just kind of skipping that because I know we got 3 minutes. All right? Now, combine like terms. Let's move everything over. Okay? So 2x squared minus x, that's x squared, plus 5x. And then negative 10 plus 4 is a negative 6. Equals 0. Do me a favor, guys. Hold off putting stuff away so I don't have to fight the noise. Let me do this next part really quick. I have to solve for x. Guess what I got to do again? X method. So 1 times negative 6 is negative 6. This is a positive 5. The two numbers that multiply to negative 6 and add up to 5 will be a plus 6 and a minus 1. Okay, that'll give me x plus 6. We're almost done. X minus 1. So, 2 more steps, okay? Smaller steps. So here you go. Each one of these can get their own mini equation. And here are your two answers. Again, this will be posted for you guys, so you can always write them on your own notes a little bit later. Okay?